Another special type of expression we're going to look at in terms of factorizing is something called a quadrinomial. So a binomial is an expression involving two terms. A trinomial is an expression involving three terms. A quadrinomial is an expression involving four terms. So as an example, 3x plus 4y plus 6ax plus 8ay. So terms are separated by plus or minus signs in this case, and there's four of them. So this is called a quadrinomial. So quadrinomials may be factorized by grouping in pairs. So we group any two together, usually the first two and the sort of the second two terms, and then we try and factorize them and see if we can find something in common. Not always possible. Sometimes we may have to move terms around to make it a little bit easier. Either way, this example here, so 3x plus 4y plus 6ax plus 8ay, we could either factorize it sort of with all the terms in place, or we can switch a couple of the terms around. And usually you just switch the middle two terms around and we can see an easy factorization. In fact, I'm going to show you both ways. So let's factorize this quadrinomial with all four terms sort of in place and looking at the first two terms and the second two terms separately. So in this case here, okay, you have 3x plus 4y. I'm going to put that in brackets, plus, okay, you have 6ax plus 8ay. Okay, so I'm going to group those together. Okay. Now, the first pair of terms, there's nothing we can factorize out of that. But let's have a look at the second pair of terms. We can take out, okay, I'm just going to write the first pair there. But the second pair of terms, we can factorize out a 2 and an a. So this becomes 2a, and this will be 3x plus 4y. We can see here that we have identical brackets now. So we have the 3x plus 4y, and we also have the 3x plus 4y here when we factorize the second pair of terms. So that identical to this one's identical as well. So taking both of them out, we can take this out as a common factor, in fact. So 3x plus 4y, okay, so we can take that out as a common factor first. So it's like you're dividing both of these terms by 3x plus 4y. And that leaves behind one lot of 3x plus 4y and 2a from the other pair of terms. So the factorized quadrinomial is 3x plus 4y outside of 1 plus 2a. If you expanded that using the extended distributive law, you should end up with 3x plus 4y plus 6ax plus 8ay. And of course you would. The other way that we can factorize this, and just if you didn't see that sort of immediately, I'll show you sort of the other way, is if we swap the two middle terms around. So, and you're allowed to do that actually, so it doesn't really matter. If it makes life a little bit easier for you, by all means swap these two around. And you'll see what I mean in a moment. 3x plus 6ax plus 4y plus 8ay. The first two terms now, I think it's sort of fairly obvious what you can factorize out. In fact, you can factorize out 3x, couldn't you? Okay, and then you end up with 1 plus 2a. The second two terms, okay, we can factorize out we can in fact factorize out 4y, couldn't we? Yeah, and you end up with 1 plus 2a. So this is just sort of basic common factorization, but applied to one pair of terms at a time. But notice how that by changing or I guess transposing the two middle terms, we can see the factorization maybe a little bit easier. Not necessarily more correct, I'm just saying that it's just another way of doing things. Now, 1 plus 2a is the common factor now, because it's the same binomial in both of these terms, and that leaves behind 3x plus 4y. So notice it's the same solution as what we had gotten before, just the two binomials just written back to front, or sort of one behind the other, as opposed to the first time around. I think we had 3x plus 4y first, outside of 1 plus 2a. So it doesn't really matter which order you write them in. Let's have a look now at just a few other examples. Okay, so the first one, In fact, what I might do is I might actually I'll leave it as it is. I was going to change it slightly, but I think I'll just leave it. X cubed plus x squared plus x plus 1. Again, on the surface, it doesn't look like you can factorize much out of this one. X plus 1, well, you can't sort of do much there. If you want to, you could maybe sort of swap terms around, but I don't know if swapping terms around here is going to do anything. But let's have a look at the first two terms. Okay, if you take out x squared as a common factor, we end up with x plus 1. Now, the second pair of terms, x plus 1, the only thing you can factorize out of that is, in fact, the number 1. Now, I'm going to write that, in fact. So that's plus 1 outside of x plus 1. And the reason why I write plus 1 is because it's actually one lot of x plus 1. So that's why by taking out a common factor of 1, you're just making it more explicit that what we're going to do next. You can see what's going to happen, why we're going to do what we're going to do next. In fact, we have x plus 1 now as a common factor, okay, in both of these terms. So take out x plus 1, but then what do you leave behind? You leave behind an x squared plus 1. So see why I had to put the plus 1 there? Even though we don't write, in algebra, we don't write sort of 1x or 1 outside of a bracket because it's implied that it's one lot of that anyway. But by reintroducing the plus 1 or minus 1, depending on the expression, by reintroducing that, it just makes the factorizing a lot easier because you know that the correct answer, in fact, it has to involve an x squared plus 1, not just x squared on its own. Right, let's have a look at part B. So x outside of a minus b plus y outside of b minus a. Now, this sort of would be quite trivial if the two brackets were in fact exactly identical, but it sort of be nice if we had an a minus b here. It would be nice. So in other words, the b has to be negative, but the a has to be positive. So how could we achieve this? So to get the same the same sort of same bracket, in fact, the same binomial, identical. In fact, if you multiply this binomial, okay, so by -1, you might think, okay, so I'm multiplying this bracket by -1, that'll make the b a negative, so you get minus b. That'll make negative a positive, since negative a times -1 gives you positive a. But then we sort of have to undo this multiplication by -1 on the outside. So we're going to multiply the y by -1 as well. So what we're going to end up with then is x outside of a minus b, so that sort of nothing happens there. But then instead of plus y, it's going to become minus y outside of a minus b. After all, multiplying the bracket by -1, or what's inside the brackets by -1, just changes the sign of all the terms inside the bracket, doesn't it? Okay, so in other words, we're making the b negative and we're making the a positive, a minus b. But you need to undo that operation on the outside. You can't just multiply things sort of randomly by negatives and expect the answer to stay the same. It needs to be compensated for somewhere else. So we're compensating for this multiplication by -1 by multiplying by -1 on the outside. So -1 times -1 is just +1, nothing happens. So there's no change in value, just change in form only. So moving on, we now have an a minus b as our common factor, and that leaves behind x minus y. Okay, right, last one. We have a b outside of y plus 2 plus z outside of y plus 2 minus mb minus mz. Okay, so let's see what's going on here. Now, the first two terms, so this is b times y plus 2 plus z times y plus 2. Y plus 2 is a common factor. So why don't we take that out first and see what's going to happen. You have b plus z. And we can factorize out, in fact, negative m. So we've got minus mb minus mz. So why don't we take out negative m, and that leaves b plus z. Sort of in brackets there, kind of what's left over from the factorization there. Now let's look at the new expression that we've just formed. We have b plus z now is also a common factor here as well. So let's factorize it a second time around. Take out b plus z as a common factor, and now you end up with y plus 2 left over, but then we have minus m. So you end up with a binomial multiplied by a trinomial, which is kind of interesting. But it's interesting that even though it results in a trinomial, we're still applying the principle of grouping in pairs and treating it like a quadrinomial, in fact. Technically speaking, it is a quadrinomial. That's one whole term there. That's another whole term there, because it's separated by the plus and minus signs. These, not the ones in brackets, the ones outside of the bracket. So you've got one term, one term, one term, one term there. So we're treating it as an expression involving 4 terms. So we're still using the same principles of grouping in pairs.